All right, guys, STAT1800. This is the final exam study guide. It may seem a little bit counterintuitive here for me to put up the answers to this assignment when it's actually being counted as a grade. But what I think about is, there's so much at stake with your final exam. Not only does it contribute, almost 40% of your final score or your final grade. For those of you that didn't do as well in the midterm exam as you had hoped, you can completely erase that with the final exam score. So in other words, if you, just an example, if you say you got a 50 on the midterm, but you get a 75 on the final, then you get to replace the midterm with a 75. So you'd have two 75s instead of a 50 and a 75. So let's see, I don't want to install that. I don't know why that came up. But anyway, so what I'm going to do is, the final exam's comprehensive, so there's just a lot of stuff on it, So I'm going to put up multiple videos. My goal on this video is to put up the solutions for questions 1 through 4. I think there are about 30 questions. So when I post these to Blackboard, let's say you've done well on all questions, but you have a problem, an issue with maybe, as an example, question number 7, then all you have to do is go to the video that contains that question. So anyway, I've talked enough. Let's get busy. So I'm going to bring up, and again, so there's no misunderstanding. You get credit for this. It's a 100-point assignment, just like the other assignments that you've had throughout the semester. And again, it seems a little goofy that I'm going to do these for you. But again, because of the nature of the final exam and the high stakes of the final exam, that's the reason I'm doing this. Okay? So you're given some information that's collected on students from a campus bookstore, foot length, number of magazines purchased. So you want to classify these as categorical or numerical, and if they're numerical, you want to classify it as continuous or discrete. The guys, remember, categorical means it just falls into a group. Numerical discrete means that it's a number, but it's countable. Number or numerical continuous means that it is a number, but it is measurable. So foot length is what type of variable? Guys, we would measure your foot length, so this would be numerical continuous. All right, cool. Second part, I thought we were going to a new question. The number of magazines purchased is what type of variable? Well, I personally subscribe to 3 magazines, so I count those 1, 2, 3. So it's a number, and because it's countable, it would be a discrete measure. And academic major, mathematics, physics, nursing, whatever it may be, should be no surprise that's categorical. Wouldn't it be cool if it stayed this easy? Dorm hall of residence, well, that's, the name of the dorm. Okay, the data set below shows the overall miles per gallon for a group of, so let's see what we need to do. We need to do the first quartile, third quartile, and IQR. So we need to list the 5-number summary, and we need to construct a box plot and describe its shape. So guys, I'm going to take this into StatCrunch, and again, you'll have StatCrunch available to you on the final exam. So always check that first row, and the reason is there's sometimes, well, I'm just having fun apparently. Sometimes that variable will be embedded as the first row, so make sure your first row actually does start out with the first piece of data. So guys, what we want here is we want to go stat, we want to go summary stat, and we want to go to column. And we want to select the column, and then we want to do some 5-number summary stuff. So guys, I know I need the median. I know I need the minimum, the maximum, Q1, and Q3. See, I've already looked ahead and seen that it wants us, also wants us to do IQR. So I've already gone ahead and read the question, so I know what I need to select when I get here. So let's go ahead and go compute. So I'm going to write this down. So my median equals 21. My min is equal to 17. My max is 28. And Q1 is 19. Q3 is 24. So the IQR is equal to 5. All right, so when I go back over to enter the answers, the first quartile was 19. The third quartile was 24. And the interquartile range was 5. Again, start you out with some easy stuff so we can maybe get some confidence right. So the 5-number summary is the minimum score, which is 17. Q1, which was 19. The median, which was 21. Q3, which was 24. And the highest score, which was 28. So the 5-number summary is the minimum score, the maximum score, Q1, Q3, and the median. Now construct a box plot. So guys, we need to come back over and do that. So I'm going to go to Graph. I'm going to go to Boxplot. And guys, we want to make sure that this box right here, use fences to identify outliers. Make sure that is selected. So again, when I see that I have no outliers, and I see a pretty symmetric distribution. Now this tail right here is longer than that tail, so it has a little bit of a positively skewed distribution. So when I come down here, I'm trying to find the one that has a maximum value of 28. So this end bar, this end vertical line has to line up with 28. And we see it does here, and it doesn't here. So C is out of commission. It's not. There's no way. And we can see that since this has a little longer tail than this side, it makes sense to us that A would be the correct answer. So what is the shape? What it wants you, the distance from the small is, the median is the largest value. Okay, so if we look at our distance from 21, we can see that from the median to the smallest goes from 17 to 21, so that's 4 units. And 21 to 28 is 7 units. So because the distance from the median to the high score is higher, we have a right skewed distribution. Okay, now, gang, this is one of the most confusing questions for students on the final exam, because they forget that this is a discrete probability distribution, and they forget the formulas. So guys, I want to go back over and just remind you, in a discrete probability distribution, and you know you've got one of those when you have X values that are countable, and then you have probabilities of those that are given in the right column. It turns out that the mean is equal to the sum of the X's times those probabilities. So what I'm going to use is I'm going to use StatCrunch to do these calculations for me. So I'm going to enter this into StatCrunch. And all I have to do is multiply this first number times the second number and add those up. Well, I'm going to create a new variable here. So I'm going to go to Data, Compute, and do an expression. So my expression, I'm going to go to Build, and I am going to take the accidents times the probabilities. And I want to store those, okay? So I'm going to go OK. And I'm just going to call this the mean, because that's what I'm going to use to calculate the mean. Now, all I need to do now is sum this up, so I can go to Stat, Summary Statistics column, the mean column, and then I just need to come down and find the sum, and I've got the mean. So the sum is 1.66, so the answer for the mean will be 1.66. Now, it's going to ask for the standard deviation next. Now, the standard deviation formula is the square root of each of the x values minus the mean quantity squared times the probability. So, we need to sum all these up. Forget the summation. So we'll take each x, subtract the mean, square that, and multiply it times its probability. We'll sum all that up, and then we'll take the square root of it. So the way I would do this is I would go back to StatCrunch, and I would create a new variable here. Okay? So I'm going to go Data, Compute, Expression. And guys, let's think about what we need. We need what? Well, let's build this thing. We need the x values minus the mean, which was what, 1.66. And then we want to square that. And then we want to multiply it by the probability. Okay, so now I've got my values. What I need to do now is take the square root of the sum. So I'm going to go ahead and get the sum first. So the sum is 2.7844. So now I'm just going to grab my calculator and take the square root of 2.7844. And when you do that, you get 1.6686. So I'll go back, and it wants me to type to 3 decimal places. So I'm going to go 1.669. Now, the people who missed this last time I taught 1800, the students who missed this on the study guide and on the final exam, they did everything correct, but they forgot to take the square root. So guys, just keep that in mind. You get two sheets, two pieces of paper, front and back of notes. So that might be one of those things that you want to put on your cheat sheet, so you won't forget. All right, guys, we're given a normal distribution with a mean of 50. And a standard deviation equal to 4. So we have 4 parts, and we want to find probabilities. So gang, to do that, the first thing we want to find is probability of x greater than 45. So gang, to do that, you're going to go to Stat, and you're going to go to Calculator, and you're going to go to your normal. And again, the mean was 50. Standard deviation was equal to 4. And we want x greater than or equal to 45. So I don't know how far we're supposed to go out. I'm going to write it out to 4 places. So 0.89435. I'll just go out to 5 places just to be sure. So it wants us to go to 4 places. So I'm going to go 0.89435. That's not cool. Okay, what is the probability x is less than 42? Well, same stuff, essentially. So to 4 places, it would be 0.0228. All right, for the distribution, 8% of the values are less than what X value. So guys, when you look at a visual of this, smack dab in the middle is 50%. So I know something down here has 8% below it. So I've got to use StatCrunch to figure that out. So so guys, you know, same mean, same standard deviation, and I need less than because I need 8% in this lower tail, but this time I'm going to put the 0.08 there and solve for the X value. So 44, let's see how it wants us to round it, round to the nearest integer, okay? So it looks like this is going to be 44. And the final one, between what two X values symmetrically distributed around the mean are 60% of the values? Well, a picture is going to really help here. So what we want is we want surrounded around the mean of 50. We want the values where the middle 60% of the distribution fall. So guys, again, let's think about it. Underneath the curve, we have 100%. We subtract the 60% and we see that we have 40% remaining in this tail and this tail. So I need half of that 40%, 20% to be in this tail, and I need half of it, 20% to be in this tail. So I'm going to find this one first and then this one second. All right. So go to my StatCrunch, same mean, same standard deviation, but in the left tail I need 0.20 below that. So I get 46.63. Let me see how much what it wants us to round to. And this is round to the nearest integer. Okay, so that makes it simple. So then this would be 46 right here. Now to find this upper tail, all I have to do is just go greater than, and I want 0.2 in the upper tail, and I find the X to be 53. So between 46 and 53 are the values I'm looking for. Now this was a commonly missed problem the last time I taught STAT1800. So, okay, what did we do wrong? All right, well, what's going on here? 60% round to the nearest integer is needed. Mean of 50, standard deviation of 4. 60% between. All right, guys, what's happening here? We need, so 53. 0.2. So maybe it wants us to round up, maybe 46 and 54. Huh, I'm confused. I don't know why we missed that. So maybe 47, round to the nearest integer. 54. Oh yeah, I'm completely and totally confused. All right, let's figure this out so you guys don't get caught into that. Oh, I see. Whoa. I didn't round correctly. That should be, you guys are probably screaming at the, I got sloppy is what I did. And this is exactly why that I go through and grade all of your final exams by hand, is because you wouldn't need to miss just because of rounding. So I see it's 47, and then when we do the upper tail, and put in 0.2. So guys, I got sloppy there. It would be 53, so 47 and 53. So sorry about that. Now let's go ahead. I was just going to do the first four, but let's go ahead and just do the first 5 questions. So the diameter of a brand of tennis balls is approximately normally distributed with a mean of 2.66, standard deviation 0.05. Random sample of 10 tennis balls is selected. What's the sampling distribution of the mean? Well, guys, because we have a normal distribution, the distribution of the sampling distribution of the mean will be normally distributed. So we can select A with confidence. Now, guys, remember, for the sampling distribution of the mean to be normally distributed, then the distribution we're pulling from has to be normally distributed, or the sample size has to be large, which means 30 or higher. What is the probability that the sample mean is less than 2.63? So again, we have a mean of 2.66, a standard deviation of 0.05, and a sample size of 10. So we want less than 2.63. Now, guys, what happens here is a lot of students will put in the 2.66 correctly, but then they'll put the standard deviation in as 0.05, and then they get the problem wrong. The reason is when we take the sampling distribution of more than one at a time, and we look at the probability of the mean, then we have to divide this by the square root of the sample size, which in this case is 10 tennis balls. Okay, so we want less than 2.63. And we'll compute, and we get 0.02888888, so we should be able to remember that. So we want 4 places, so 0.0289 would be the answer. Now, what is the probability the sample mean lies between 2.65 and 2.67? Well, guys, this is going to be, again, a very easy problem. So we want to select between, and we want 2.65 and 2.67. So 0.4729. And then it looks like the final, A through D, the probability is 68% or 0.68 that the sample mean will be between what 2 values. So we went around to 2 places here. So that's what I can do is I can do the between, but I want, let me go back and make sure I got this right, 68%, okay? So I want the value to be 0.68, and I want to solve for the 2 values. So 2.64 and 2.68. All right, gang, I'm going to end this video, first 5 questions, so there's more coming on. All right, take care.